Okay, so to start with, we need to make sure that we can, type these sine, cosine, and tangents into our calculators. Once again, every single 25-degree angle. So this is what I want you guys to understand. So if I have a right, because trig is always used with right triangles, every single 25-degree right triangle has the exact same ratio of the opposite side over the hypotenuse. And every single time, and again, I can build a larger one. So here's a larger 25-degree right triangle. Again, notice the opposite side has grown, but so has the hypotenuse, and they grow at the same rate. So what your calculator does is when you type in the sine of 25, and again, your mode has to be in degrees. If you need help, you can ask me. But when you actually just click in your calculator, sine 25, it comes out to a decimal. It comes out to approximately 0.4226. Okay, I always round mine to 2 decimals. So you guys are going to see this as approximately 0.42. And again, that's the ratio of the opposite side divided by the hypotenuse. No matter what size your triangle is, the ratio of a 25-degree angle is, of the opposite side over the hypotenuse is 0.42. Okay, we're going to practice again. So here is the cosine of 25. So again, if you type in cosine of 25, I'm getting that that's approximately 0.90. And again, if you have this right triangle and you have a 25-degree angle, the ratio of the adjacent side to the hypotenuse, every single time you divide those numbers, it's going to give you approximately 0.91, I should say 0.91. My rounding is off, and that's going to bother me. So 0.91. And then the tangent, let's just say 58. And I'm getting approximately 1.60. And again, that's if you have a right triangle with a 58-degree angle, the opposite side divided by the adjacent side is going to be about 1.6. Okay. The next thing we're going to practice is finding an angle measure. So if we were actually looking for an angle measure, and for example, they're telling you that the ratio of the sides is 2 to 3. Okay, that's what this is what this means. I have a right triangle and I have some angle. We call it theta. So usually you guys are going to see a circle with a line through it. That means theta. It's saying that the opposite side is 2 and the hypotenuse is 3. They're asking us what angle is that? Okay, so every time the opposite side divided by the hypotenuse, every time that's 2 to 3, what angle is that? So what we're going to use is we are going to use inverse. So you guys are going to see in your calculator a sine -1 button, and then you're going to press 2 divided by 3. So inverse sine of 2/3 is approximately 41.81 degrees. So that tells me that that angle is about 41.81 degrees. Again, here's a cosine. So we have a right triangle, just so you guys can visualize it. They're asking me what this angle is if the adjacent side is 1 and the hypotenuse is 2. So again, we're using that inverse cosine button of 1 divided by 2. And I'm getting 60 degrees. And again, guys, that makes sense. Obviously, this side would then be root 3 in our 30, 60, 90 triangle. And the last one, we're using inverse tangent of 0.4. And here I'm getting it's approximately 21.80. Okay, so make sure you guys are practicing on your calculators. Make sure you guys are getting these numbers. The next thing is how we're actually going to start applying and how we're going to actually start solving this. So the first thing we need to do is we need to figure out, so I see a combination of angles and sides. And when we have a combination of angles and sides, we know that we're going to be using trig. So we need to identify if we're using sine, cosine, or a tangent. And so you'll see this acronym of SO, CA, TOA, because sine represents the opposite in the hypotenuse, cosine is the adjacent in the hypotenuse, and tangent is the opposite in the adjacent. So because we're working with this 18-degree angle, that's called my reference angle. We are going to label the sides based on that 18-degree angle. So I always start with the hypotenuse. Okay, so we have this hypotenuse right here. The next side I usually label is called the opposite side, and in this case we're not working with that at all. And then my last side is the adjacent leg. So because I'm working with the hypotenuse in the adjacent leg, I know I'm going to be working with the A and the H, which is cosine. So my calculator knows that the cosine of 18 degrees is equal to the adjacent side divided by the hypotenuse. And so we need to figure out what the hypotenuse is. So your calculator knows that every single time that you have an 18-degree angle, the cosine, or in other words, the ratio of the adjacent side over the hypotenuse is, and let's see, cosine of 18, it's telling me that that ratio has to be approximately 0.95. Okay, so what I'm going to do is I'm going to show you guys two different ways of solving this. One of them is called the exact method, and you guys will see this on the SAT a lot. And then this is the rounded way. Okay, so again, the cosine of 18 is 0.95, and that's still equal to 10 over h. Okay, with both of these, we need to solve them. I like to just go ahead and put this over 1, and then we can go ahead and cross multiply. So when you cross multiply, you have 10 is equal to the cosine of 18, times h, divide by the cosine of 18, divide by the cosine of 18, and so h is equal to 10 divided by the cosine of 18. As you guys go through this, another thing you can remember is the means extremes product theorem. And if you remember that, you know that 1/2 is equal to 4/8. Well, when I switch the means or the extremes, 8 over 2 is equal to 4 over 1, it remains true. So all I technically have to do is switch the cosine of 18 for the h, and I'd immediately get to this answer down here. Okay, so that helps me with this little shortcut. So when you have a variable in the denominator, again, you can switch it with the numerator of its equivalent ratio. Over here, I'm going to use that same tactic. So I'm just going to go ahead and flip this right here. And we have h is equal to 10 divided by 0.95. And again, because this is a rounded answer, we can actually go through and type this in. 10 divided by 0.95. And I'm getting that h is approximately 10.53. Okay, so my hypotenuse in this case is approximately 10.53. Now again, these are just different representations for the same answer. My problem right here for number 2, we're going to go ahead and solve this triangle. So when you see to solve the triangle, that means you need to come up with all of the angles and side lengths. So I already have a 15 and 17, and so hopefully you know that the missing leg here is going to be 8. If not, you know that you can go ahead and use Pythagorean's theorem. So we know that the side length is 8. The next thing we need to do is come up with all the angle measures. So we can see that one of the angles is 90 degrees, and I'll just, for reference, A, B, and C. So we know that angle B is 90 degrees. We still need to find angle A and angle C. So it's up to you wherever you want to put that little theta marking. I'm going to put it at A. So I'm just going to mark this with what's called a theta, and I'm going to label my sides after that. So again, we're working with the hypotenuse, and obviously this is my opposite side. So because I have the hypotenuse and the opposite side, I'm looking for an angle, I can say that theta, or the angle, is equal to the inverse sine of the opposite side over the hypotenuse. Okay, so again, I'm working with inverse whenever I'm looking for an angle. So inverse sine of 15 divided by 17. So I'm asking my calculator what angle measure has the ratio of 15/17, and my calculator is telling me that theta is approximately 61.93 degrees. So that's angle A is approximately 61.93 degrees. Therefore, angle C is just 90 minus that, so about 28.07 degrees for angle C. And this is, again, how you solve a right triangle. You come up with all the angle measures and all of the side lengths. The next thing I want to talk about is something called angle of elevation and angle of depression. So angle of elevation is, picture a person standing down here. It's how much your head is looking to look up at a flagpole or to look up at the top of a tree or the top of a building. Whereas angle of depression, the person's standing up higher and their natural sight line is straight ahead of them. Well, they are looking down to see, I think a lot of problems have like boats in them, to look down to see a boat. Now keep in mind that because we know about parallel lines, our sight line is going to be parallel with the ground, therefore making congruent Zorro angles, as I like to call them, alternate interior angles. So this angle of depression is the same as this angle that the person at the boat has to look up to see from their sight line. So those are congruent to each other. So just some things to keep in mind. So from the top of an observation tower, 60 meters high. So the first thing I'm going to do is I'm going to draw an observation tower, and that tower is 60 meters high. A forest ranger noted the angle of depression of a hurt camper was 5 degrees. So he's at the top of an observation tower. Okay, so he's looking through binoculars, and he noticed that the angle of depression of a hurt camper, so here's his eyes normally going straight out, but he had to look a little bit farther down. Okay, that's the angle of depression at 5 degrees. Okay, and there's a hurt camper, so laying down here, here's the hurt camper. I don't know why I keep putting the hands coming out of the head. Okay, it says how far was the camper from the base of the tower. So this is what we are looking for right here. And as you can see, I'm building in your right triangle. I'm also building in this little 5 degree Zorro angle. Therefore, this angle right here has to be 5 degrees. Using this triangle, so we have this orange triangle right here. I'm mixing my angles and my sides. So I'm going to label my sides. So my hypotenuse, which again, I know nothing about in this case. I have my opposite side, opposite from the angle, and my adjacent side. So I need to tell my calculator that because I'm working with opposite and adjacent, I'm working with the tangent. So my calculator knows that the tangent of 5 degrees, what that's going to be, and the opposite side over the adjacent side, again, using the means extremes product theorem, I know that x is equal to 60 divided by the tangent of 5, and that is called an exact answer. If that's what they asked for, you would leave it like that and call it a day. We're going to actually type this in and we're going to try this. So 60 divided by the tangent of 5 degrees. And my calculator says it's about 685.80 feet. I believe this was in feet, meters, scratch the feet, change it to meters. So it's about 685.80 meters away. So that's how far the hurt camper was. Okay. Once again, just some extra practice here. So with this one, this is not a 3-4-5. If it's not a 3-4-5, you have to use Pythagorean's theorem. So this is 25, this is 9. I add those together, so x is the square root of 34. Okay, next we're going to be finding theta, and so I need to know that I'm working with the opposite side and the adjacent side, and so therefore the theta is going to equal inverse tangent of 3/5. So I'm telling my calculator that the opposite and the adjacent side have a ratio of 3/5. What angle is it? And my calculator is telling me that that angle is 30.96 degrees. So in this case, I'm finding theta. Right here, again, the only thing I'm asking for is x. That's a side length. So I'm working with my hypotenuse. I'm working with the opposite side. Therefore, I need to tell my calculator sine. So the sine of 22 is equal to the opposite side over the hypotenuse. Switching these at this point using means extremes product theorem isn't helping. So in this case, I'm actually just going to multiply by 10. So x is equal to 10 times the sine of 22. So if you don't have a calculator or if they ask for exact answers, that's how you would leave it. If you do have a calculator, you're just going to type in there 10 times the sine of 22. And I'm getting that x is approximately 3.75. Okay, so my calculator knows that if you have a 22-degree angle, and that kind of makes sense because this is not drawn to scale, a 22-degree angle, it's not even a triangle, a 22-degree angle is pretty narrow. So if you think about it, if the hypotenuse is 10 and this is 22 degrees, it makes sense that this is about 3.75. It shouldn't be that long of a side in relation to the hypotenuse. Okay, and that is it for section 9-10.